Okay, in this video I'm going to go over the solutions to the polymers practice. All right, so for the first question, it asks you to do two things. First of all, draw 4 repeating units of the polymer made from a particular alkene, and then to give the square bracket notation to represent the polymer made from it. All right, so the first one is propene, all right, which is actually more commonly referred to as propylene. All right, so again, the way that you want to do this is by first draw the starting material so that the double bonds are shown at an angle like this. All right. If we drew the polymer reaction, we would show this double bond, electrons from this double bond attacking this carbon, this double bond attacking this carbon. And so one way that you can do this to make sure that you get it right is if you drew it like this, you could erase one of the double bonds and then draw in a single bond that connects the carbons diagonally like this. All right, so if you did that, you would end up getting this is what 4 units of that polymer would look like. All right, notice I draw a little squiggly line here and here to indicate that this would continue on in that direction. It would also continue on to the left. All right, and you can see here, if there's 3 carbon units. All right, so each of these is 3 carbons. So 1, 2, 3, that's 1 unit. 1, 2, 3, that's another one. 1, 2, 3, 1, 2, 3. All right, so that's what these right here just indicate is it shows where the 4 units are of that starting monomer to give that polymer right there. All right, so if I'm going to do the square bracket notation, a good way to do this is to say, well, the square bracket notation should be around the part of it that would originate from the monomer. All right, so this is the monomer right here. All right, so inside the brackets we should have carbon, carbon, carbon. All right, so carbon, so that would be this right here, that part of it. All right, and what you're doing is the brackets are going to be basically be drawn through the bond that gets created when the polymer gets made. All right, so notice that the bond that gets made when the polymer is made is from here to here. All right, so that would be correspond to this bond right here. So that's why I'm putting the bracket there. All right, notice that there's a bond that would have gotten formed, to here. All right, so that's why this bond is right here. All right, and so a way that you can prove to yourself that this is this would be a way of doing it is, if you were to take this part right here and just cut that out. If we just had that piece of paper and you cut that out, and you made 4 copies of the piece that you cut out, you could take those 4 copies, all right, and lay them end to end. All right, and when you so you take the left side of one and connect it to the right side of the other. All right, and you notice you'd end up making this this chain right here if you had enough of those right there. All right, so to do this for ethene, which is more commonly called ethylene, all right, ethene is just 2 carbons, a 2-carbon alkene. All right, you would end up making this right here. Notice that if there are 4 units of it, well, since each monomer's got 2, if we make 4 units, there should be a total of 8 carbons in that section. 2, 4, 6, 8. All right, notice I put the squiggly lines where the bond would come in here. So we put a little squiggly line to indicate that it would be continuing to the left. We also put a squiggly line where it ends off over here. And if we were to draw the square bracket notation, it would look like this. All right, and again, if you took a bunch of these and you photocopied them and you tried connecting them end to end, you'd see that just doing this, connecting the left side of one to the right side of the other, would end up giving this polymer right here. All right, 1-butene would look like this. All right, same basic concept. All right, and the last one, I've decided to do it a little bit differently. First of all, for styrene, all right, if you look up styrene, this is the structure for it. All right, and if you notice one thing I did in all of these right here, I always drew the alkene and I drew whatever's coming off the alkene coming off the bottom. All right, but we could have also done it where we drew the alkenes, but then we drew the substituent with the group coming off the top. All right, it's just personal preference in how you draw this. All right, notice I could just as easily I could turn this structure around to have it look like this, but I also could have had it like erase this top part and have that phenyl group coming down here, all right? And that would be more like what I did here. Either way, you're going to end up getting the same chemical, all right? So if we draw this right here, all right, this would be 4 units, all right? And so what's the name of the polymer that we get when we polymerize styrene? That's polystyrene, all right, which is, you know, most common form of that is styrofoam, all right? So, and to draw this as the square bracket notation would look something like this. Notice that within the square brackets, I have 1, 2, 3, 4, 5, 6, 7, 8 carbons. All right. Within the square brackets, you should have the exact same number of carbons as you do in the monomer, or the starting alkene that went into making it. All right. So one of the things that can get you in trouble with drawing the square bracket notations. So, for example, on this right here, think of a square bracket going and breaking that bond right there. One thing that could get you into trouble is if you were to draw a square bracket coming here so that you actually include more than just one monomer in that. All right. So notice I don't have this there. Yes, this carbon right here would correspond to this carbon right here, but that's not within the brackets. All right. So another one right here, I want to point out that I did make a mistake. For this to be drawn correctly, you shouldn't have the squiggly line here. You should actually have a squiggly line going through a bond right here. All right. So what we're going to do is say, well, if this is the polymer, what is the monomer that was used in making it? All right. So remember, the bond that ended up getting formed was from here to here. That's the bond. All right. And so this bond right here was always where you had your alkene. All right. So this is the bond that gets formed. This is where the alkene was. All right. Same thing before. So take a look by comparison. All right. This is the bond right here that was the alkene. And this is the bond that got formed when this bond right here got formed. All right. So what we have to do is kind of work backwards when we're doing this. All right. So this one right here needs to be the double bond, and this bond would no longer be there. All right. So this right here would be the monomer. All right. So you could prove this if you drew 4 of these side by side and then drew your polymerization reaction. All right, where you erase this double bond right here and you make this connection between those 2 carbons. All right, and you kept on doing that, you would see that you would end up getting this polymer right here. All right, so the name of this particular monomer, all right, is butene. All right, I think people would more commonly call it 2-butene. All right, but according to the official IUPAC rules, that would be its name. All right, for this guy right here, this would be the monomer. And I do want to point out a bit of just being consistent here. Even though most people would recognize what this is representing here, I would encourage you either to draw it as just the line angle where you don't draw in hydrogens off the carbons, all right, and you don't draw in the carbons either, or to draw it with the carbons and the hydrogens shown. All right, notice that when I drew it like this, I'm drawing it as kind of a hybrid where I'm not drawing in the carbons, but I am drawing in the hydrogens. And even though I would accept this, in terms of how it seems that the IB expects that structures to be drawn, they would expect either one type, either line angle like this, or with the carbons and the hydrogens drawn in. All right, and the name of that monomer is chloroethene. But a more common name for that is called vinyl chloride. All right, so this chemical right here, its common name is vinyl chloride, and so when you make a polymer from that, it's polyvinyl chloride. All right, and polyvinyl chloride, PVC. All right, so PVC pipes are just this polymer right here.